Okay, we'll start. So once again, good morning to everyone. So today also we start with our practical session. Okay. So in last practical, in we can discuss how to convert the one color model into the another color model. Okay. So by using a simple program, we can study how to convert the RGB color model into the CMY color model and how the image will look like in the CMY color model. Okay, so similarly we can convert any color model into the another color model. Okay, so in for our syllabus we can study the three different types of color models: RGB, CMY, and HSI color model. So we can convert the one color model into the another color model by using a MATLAB coding. Okay. So for today's practical, we have to study the histogram equalization. So what is a histogram and how we can equalize the histogram? Okay. So in our first unit, we can study the part of histogram. What is a histogram and what is a histogram equalization? Okay, so in first unit we can study the main concept regarding histogram is that. So first one is a histogram, then histogram modeling, then histogram equalization, and histogram specifications. Okay, so can anyone tell what is a histogram? Histogram म्हणजे काय? And how we can equalize the histogram? That is called as a histogram equalization. Okay, so by using different examples, we can solve uh, various example by using a histogram equalization. So if the given image consists of number of pixels, so it might be a 0 to 7, so we can equalize the values of histogram. So at the initial, uh, it consists of large number of gray levels. So we can equalize the large number of gray levels and we can redefine the image into the suitable format. Okay, so that is nothing but histogram equalization. So for that we can take the two functions. So one is a PDF function and another is a CDF function. Okay, so by using the histogram we can compute the large pixels into the small number of range, so it is easy to visualize the image properly. Okay, in our theory lecture we can also study the what is the image intensity at a dark level, what is the image intensity at a bright level, or what is the image intensity at a middle level. Okay, so if the image consists of large number of dark pixels, then all the histogram values are located at the left side. Okay, so why? So we can define the black pixel with the intensity as a 0. So if the image is a too dark, then all the pixel values are located at the left side uh, of the image. Yeah, we can call it as at the origin side. So if the image is a bright, then we can redefine, yeah, we can define the all the pixel values at the right side. And if the image is a combination of bright and dark, then all the pixel values are located at the middle side. Okay, so today we'll study what is a histogram and how we can equalize the image by using the histogram. And we can observe the change in image before the histogram equalization and after the histogram equalization. Okay, so first we'll understand the code of histogram equalization. Okay, so it is visible to all. Hello.
Yes, sir.
Okay, wait a minute. Okay. So when we do any coding in a MATLAB, first we need to clear the previous programs as well as its command window and workspace. Okay. So for that we can use a simply three commands, that is a clear, CLC, clear all, and close all. Okay. So these three commands are very necessary in a MATLAB coding. So in our you can use a command as a in C++, you can use a iostream conio.c conio.h. Okay. So similar to that, in a MATLAB we can use this command as a library command, CLC, clear all, and close all. Okay. So now we have to do the histogram equalization. So for histogram equalization, first we need to take a input. Okay. For input we can take a image. Okay. So when we take a image, we have to first store the image in a particular location. So here we save the MATLAB file. So in that folder we have to store our input image. Okay. So the path of our MATLAB file and the path of image should be in one folder. So if it is in a different folder, then we have to add the path. So instead of adding path, we can store the MATLAB file and image into the same folder. So here we can store the image and we can uh, give a title as a nature 1. So we can provide any title. So first we have to check the format of this particular image. So go to the properties and we have to check the format. So this particular image is in the format of JPG. So we have to provide the extension of image nature1.jpg. Okay. So first we have to take the input, and in order to read the image, we have to give the command as a im read. Okay. So first we have to take an input image. So the name of input image is the nature1 and the extension is .jpg. Okay. So and we have to store into any variable. So here we can use a variable as a variable. Okay. So this first command is clear. Yes, everyone. What we did here, simply we can take a input. So input image as a nature1 and it is in the format of JPG. So we have to provide the extension as .jpg. So it is if it is in the form of PDF or BMP, then we have to provide the extension as .pdf or .bmp. Okay, and we can store into the variable a. Yes, now understood? Yes, first command is understood.
Yes, sir.
Okay, so now we have to uh, we have to display the various image. Okay, so now here we have to display the different type. So we have to display the uh, 5 types of image. Yeah, we have to provide the location for 5 images. Okay, so we can use the subplot command. So here we have to display total 5 images. Okay, so for that we can use a sub command as a 2 comma 3 comma 1. So we can use 2 rows, 3 columns, and a particular position. Okay, so by using this subplot command, so first is indicate number of rows, second value indicate number of column, and third value indicate its a position. Okay, so we can use a subplot command as a 2 comma 3 comma 1. So at first position our input image will be displayed. So in order to display the image, जर आता आपल्याला image display करायचे असेल, so to display the image we have to use the im show command. Okay, now we'll move to the second step. So to display the image we can use a command as a im show, and we can provide the title to the image as a im show, sorry, as a rgb image. So it is in the format of rgb image. So at a first position, we can easily identify the input image. So if we run only this program, okay, so I'll run only, instead of running total program, I'll run only the first command up to the rgb image. Okay, so I'll run only the, I take the only input image and provide the title as a rgb image and will run the code. Yes, okay. So only the RGB image will display by using a this command. So it is visible.
Yes, sir.
Okay. So we can run only the first two command. The कोणती command run केली आपण? First we can take a input and give the subplot, and to display we can use a IM show and provide the title as a RGB image. Okay. So we can only run the first two lines. So by using this, uh, we can display only the input image. Okay, now we'll move towards the next code. Okay, so when we study the histogram examples, okay, so when we have to equalize the histogram, we have to always convert the RGB values into the gray values. Okay, so can anyone tell what is the reason? Sorry, what is the reason to convert the RGB image into the gray image? कोण सांगू शकते का? Yeah, we can also solve the example by using histogram equalization. So in that example also, we can study the input given data is in the format of gray levels 0 to 7. मग हा डेटा ग्रे लेवल मध्येच का आहे? Why it is not in a RGB format? असं का? कोण सांगू शकतंय? Yes, is there any reason why we can not deal with a RGB image? No one? Okay, so if we consider the RGB image, then it having a nearby 16 million colors. Okay, so it is difficult to execute, or it is difficult to read the RGB image. So for that, we can convert the RGB image into the gray image. So why gray image? It consists of gray image. It is of a 8-bit. And the RGB image is of a 24-bit. So the gray level consists of 0 to 7. So it is easy to define. So for that, we can convert the RGB image into the gray image. So our input image in the format of RGB. So in order to convert the RGB image into the gray image, so in a MATLAB there is a command RGB to gray. Is there a command? Okay, now RGB to gray. So first we can store our input image into the variable A. So here we can write command as a RGB to gray in a bracket A, and we can store into the variable as a B. Okay, so this command is clear. Why we can convert the RGB image into the gray image? Yes, it is clear.
Yes, sir.
Okay, very good. So by using RGB to gray, we can convert the RGB image into the gray image. So similarly, we have to display the gray image. Now the gray image is stored into the variable B. So in order to display, again we can use a subplot. So rows are 2, columns are 3, and at second position we can display the gray image. And in order to display, we can provide a title as a IM show and title as a gray image. Okay, now we'll run the code up to RGB to gray conversion. So we can display the RGB image and gray image. Yes, have you observed it? So first we can take a RGB image and we can convert the RGB image into the gray image and we can locate at a second position. Yes, this half code understood?
Yes, sir.
Okay. Now we'll move towards the next code. Okay. So now we have to take the histogram of gray image. So why we cannot take the histogram of directly RGB image? So the RGB image consists of, yeah, it consists of 24 bit and it consists of nearly 16 million colors. So it consists of larger intensity or it consists of large value pixels. Okay, so instead of that, we can convert the RGB image into the gray image and we can take the histogram of a gray image. Okay, so first we have to take the histogram of gray image. So how to take the histogram? So in order to take the histogram, there is a command im hist. I highlight the here. तर एखाद्या इमेजचा हिस्टोग्राम घ्यायचा असेल, so in order to take the histogram, there is a command which is called as im hist. The histogram कशाचा घ्यायचा आहे? We have to take the histogram of gray image and the gray image is stored in the variable b. ठीक है? So we can use a command as im hist b and we can display at a position 3 and provide the title as a histogram. Okay, and after taking the histogram, we can use the command as a histogram equalization. Okay, so we have to equalize the histogram and store into the variable c. Yes, so here we can take the histogram equalization of a gray image which is stored into the variable b, and finally we can use a different variable as a c. So again now we have to show the histogram equalization, right? So in order to again show the image c, we can use a subplot and we can show at a position 4. ठीक आहे, मग आता आपल्याला हिस्टोग्राम इक्वलायझेशनची इमेज शो करायची आहे. सो फॉर दॅट वी कॅन यूज अ कमांड ॲज im show c and provide the title as histogram equalization. Okay, and after that histogram equalization, again we have to take the equalized histogram. Okay, so again we can use a one subplot command and give the position as a 5. Okay, so I'll run the code and we'll observe the step by step images. So here we can show the 5 different type of image. So first image is an input image which is a RGB. Then we can convert the RGB image into the gray image. So our gray image is the second gray. Then we can take the histogram of a gray image. It will be the third image. Then we can equalize the histogram and finally we can do the histogram equalization, that is called as a equalized histogram. Okay, so I'll run the complete code and now we'll observe the change. Yes, so again I'll explain with the help of images. So everyone concentrate on an image. So first we can take a RGB image, right? So we cannot directly take the histogram of RGB image. So first we can convert the RGB image into the gray image. Okay, so first we can take the histogram of a gray image. Okay, so at third position we can plot, yeah, we can take the histogram of gray image. Okay, so have you understood the histogram of gray image? Yes.
Yes. Yes.
But if we observe the histogram of gray image, so observe the figure number 3. So it indicates the pixel values या pixel intensity. मग आता ह्याच्यामध्ये आपल्याला इंडिव्हिज्युअल पिक्सल आयडेंटिफाय करता येतोय का? सो अगेन इट कन्सिस्ट ऑफ कॉम्प्रेस्ड रेंज, म्हणजे काय आहेत ह्याच्यातले जे काही पिक्सल आहेत, सो ऑल द पिक्सल आर लोकेटेड ॲट अ इन अ कॉम्पॅक्ट प्लेस. म्हणजे एकाच्या पिक्सल झाले, we cannot identify the individual pixel. So it consists of again pixels. So for that आपल्याला काय करायचं आहे, we have to suitably locate the pixels. ह्याच्यातले हे जे काही पिक्सल आहेत, so we have to equalize, yeah, we have to define the proper pixels. So for that we can equalize the gray. Okay, now observe the figure number 4 and figure number 5. So after the histogram equalization on a gray image, we can equalize the histogram, and now observe the figure number 5. So now we can easily identify individual pixels. So now compare the figure number 3 and figure number 5. Okay, so in a figure number 3, so it consists of large pixels which are located adjacent to each other. So we have to define, yeah, we have to equalize the histogram, and we have to define the pixels at a specific levels. Okay, so for that we can take the histogram equalization of a gray image, and finally we can equalize the histogram. So in a figure number 5 we can easily identify the individual pixels. Yes. Okay, so compare the figure number 3 and the figure number 5. We can easily understood the concept of histogram equalization. Yes, it is clear.
Yes, sir.
Okay, so by using this simple program, we can take the histogram equalization of any image. Okay, so how to do the histogram equalization? So for that we have to use these 5 different steps. Okay, so again I'll repeat the 5 different steps by using the images. So first we have to take the input image. So we can take the input is a image as a RGB. So it is in the format of JPG. So we have to provide the extension as .jpg. And in order to show, yeah, in order to display this image, we can use a subplot and im show. Okay, so for the conversion we can use the command as a RGB to gray. So why we can convert the RGB image into the gray image? Because the RGB image is of a 24-bit and it consists of large number of pixel intensities. So we can convert the RGB image into the gray image by using a RGB to gray command, and we can take the histogram of gray image. Histogram of it consists of higher intensities. So if I have to define the pixels suitably, then we have to do the histogram equalization of a gray image. So it is located in a figure number 4. Okay, and now we can take the equalized histogram of a figure number 4, and that would be our final equalized histogram image. Yes, so by using this MATLAB program, we can take the, yeah, we can equalize the histogram and we can observe the histogram equalization. What is the change in an image after the histogram equalization and how the equalized histogram will be look like. So we can solve the example by using a histogram equalization. ठीक आहे, मग त्याच्यामध्ये जे आपण at a final step we can define the pixel by using a x-axis and y-axis by using these vertical lines. Okay, so that is nothing but a equalized histogram. Okay, so have you understood it?
Yes.
Okay, so okay, so for today's session, we'll take a practical of histogram equalization. Okay, so now in tomorrow's lecture, we can conduct the MCQ test on unit number 4. Okay, so again go through the notes of unit number 4. Okay, so if you have any doubt, you can discuss. Okay. Okay, so today we'll stop here. So if you have any doubt, you can ask me. Otherwise, you can put your attendance. Okay. Don't let. I'll take the screenshot of attendance. Okay, now you can left.